Ever wonder why some AI models struggle with complex tasks like math or coding? It's not because they're dumb, it's because they're stuck in a learning loop. Today, we're diving into a breakthrough called COPO, Consistency-Aware Policy Optimization. That's rewriting the rules of how AI learns. Let's unpack how this technique helps machines think deeper, not just memorize more. Here's the core problem. When AI models practice, they often generate identical answers, whether right or wrong. Imagine a student who writes the same essay for every assignment. The teacher can't tell if they're improving, so feedback stalls. This is called gradient vanishing. The AI's learning signal fades and it gets stuck in a loop. COPO solves this by introducing a global reward system. Think of it as a teacher who doesn't just grade individual papers, but also checks if the whole class is grasping the material. COPO evaluates all the model's answers across tasks, asking, are these responses aligned with the bigger goal? If every answer is identical, even if wrong, COPO adjusts the learning signal to guide the AI toward better consistency. But here's the clever twist. COPO doesn't just rely on global checks. It uses an entropy-based blending mechanism, a way to balance exploration and focus. Imagine a GPS that sometimes suggests new routes, exploration, and other times sticks to the fastest path, convergence. This prevents AI from repeating mistakes or getting lost in too many options, keeping learning dynamic. The results? COPO outperforms older methods like GRPO by up to 2.22% in math and reasoning tasks. It's also more efficient, avoiding sample wastage, where similar data gets ignored. By maintaining diversity in responses, COPO helps AI tackle real-world challenges faster, like solving a puzzle by balancing local clues with global patterns. But here's the catch. COPO works best with large, powerful models. Smaller models struggle because they lack the computational muscle to handle its complexity. It's like asking a beginner pianist to play a symphony. Without the right tools, even the best strategies fail. Let's break this down with an example. Suppose 12 friends split food meant for 18 people. A simple mistake, thinking each needs 1.5 meals. But COPO catches the proportional relationship, figuring out they actually need 8 meals total. How? It balances local clues, number of friends with global trends, original 18 meals. It's like solving a puzzle by looking at both the pieces and the bigger picture. So what does this mean for AI? Training isn't one size fits all. Big models can handle COPO's detailed roadmap, while smaller ones need simpler steps. Think hikers with trail maps, not satellite views. The key takeaway? Even the best methods can backfire if the rules don't match the model's existing capabilities. It's like teaching a toddler to drive a race car. Tools matter. The future of AI. A delicate balance. Researchers are tweaking invisible dials to make machines smarter, faster, and more adaptable. Whether it's refining reward systems, ignoring noisy data, or building better reasoning tools, the goal is clear. AI that doesn't just guess answers, but understands how to find them. What do you think? Should we focus on giving AI more complex tools, or simpler, clearer guidance? Drop your thoughts below, because the next big breakthrough might just come from your idea. Thanks for watching and stay curious.